everyone to our LTTX Let's Talk to an Expert series, an exciting initiative by Xperimentor. At Experimenter, we believe that science education should be engaging and evoke curiosity in children. Our goal is to inspire young minds through hands on and inquiry based learning. In this series, we bring you talks by experts from various scientific fields. We believe these sessions will spark curiosity and provide a unique opportunity for children to engage with experts directly. Before we begin, we have a few instructions for the session. The first one is the session is designed by Mr. Ajit to be engaging, so please feel free to participate actively. To avoid audio disturbance, we request all of you to mute yourself during the session. If you have anything to ask or contribute, please use the raise your hand option. Mr. Ajit will be asking questions throughout the session, so please use the chat box to drop your responses as well. If you have any question, please post them in the chat box. We'll try our best to address all the questions. This session will be recorded and shared on our social media handles. So today we are diving into a fascinating journey of rivers, and we have an enthusiastic guide to help us explore this epic story from mountain spring to the vast sea. Dr. Ajit, he is a principal researcher at Prayoga, specialized in hydrology, groundwater sustainability. His PhD research at IIT Kanpur provided evidence of Saraswati River's existence and its link to the Harappan civilization as well. With the postdoctoral work at Imperial College London and IIT Gandhinagar, he has contributed significantly to understanding the ancient river dynamic and the role of the cultural heritage. So, welcome to you, sir, and the floor is all yours. So, thank you. So you're muted. I'm so sorry, you're muted. Yeah.
Namaste, everyone. Thank you so much, Aparna, for the nice introduction and all the background work you did to organize this talk today. And I'm particularly excited because I'm told that there is diverse audience today. So I feel there is a plentiful scope for me to learn through the discussions, which I hope to be followed up during the talk and after the talk. So should I begin with sharing the slides from mine?
Yes, sir. Okay. So a river's journey begins in the mountains in the form of springs, and it flows through the land to the sea. And this journey is on the land space, and also on the time, because the river journey takes thousands of years. I mean, from its source to sink, it takes few years, but river has been flowing on this land for thousands of years. So this would be a journey of river through space and time. And space means land space on the earth. So quickly, outline of today's talk or discussion, we will talk about Earth system science. And because for our understanding, we have identified different systems in Earth or different spheres. One of the important spheres is hydrosphere, and how river is part of that hydrosphere or hydrological cycle. Then how do river form? Part of the river system, type of the river system, dynamics of the river system, and how evolution of river system. So these are few of the headlines I'm giving you that we will be discussing during this presentation. And while doing this discussion, we will touch upon climate, which means precipitation, temperature, wind, and tectonics, which means movement of Earth crust mainly, and energies, how
main source of energy is sun, but how that energy is distributed. So we will also touch upon to explain different river processes or river landform. Okay. So to begin with, I asked AI tool to create an image of Indian river. So this is one of the image that AI tool has created. But let's begin with our experience of a river. So I don't want your answers right now, but we will come back to your answers whenever you feel like to talk about it. Please uh, interrupt me, and or maybe I will come back to you. So the main questions that I want you to have ready with the answer is, I have visited a river. So try to recall a river that you have visited, maybe recently, long back. And I saw near that river. What did you see near that river? And if any questions, maybe then or maybe now recalling that, if you have it, please be ready with that. We will discuss this. And to help you further, like sometimes we categorize rivers according to their importance. So like scientific importance, we say environmentally, rivers are also important from environmental point of view or economic point of view, and socio-cultural importances are also there. So I'll display a few photographs, and I'm sure it will help you recall your experience with river. And of course, all these importances of river are interconnected. We cannot say one point aspect is from scientific and it is not from environmental point of view. So here are a few of the images. Like this one is showing landslide. So in science, we try to understand the process of landslide, which is related to river, then navigation of river, hydroelectricity dams created on the river, cultural importance, and flooding on the river is also witnessed sometime. And this fun activity, river rafting, which is also related with tourism. So this picture was just to highlight what is the importance of river. Now coming back to system approach. So in our basic lessons of thermodynamics, first thing we learn is system. So system is defined as the part of the universe which is under the observation, and everything around it is its surrounding. For example, in this beaker, whatever is inside the beaker, whether it's a chemical or any other substance, will form the system, and everything outside it is its surrounding. So same approach we follow in earth science. And talking about type of systems, so there could be open system, closed system, and isolated. This is classification is based on whether energy and mass exchange is happening. So when both energy and mass exchange happens, it is called open system. Closed systems only energy exchange is possible, mass exchange is not possible. And isolated system, neither of the exchange is possible. So why I have highlighted open system, because in earth system, we are mostly dealing with open systems. So all the environmental systems are open system. Now coming to the earth system sciences. For our convenience of understanding, we have divided different spheres. Atmosphere, which is a cover of gases. Hydrosphere consists of water in different form, all the forms. Liquid water, gaseous water, solid water in the form of ice and snow. Cryosphere is particularly defined for snow or glacial cover. And then biosphere constituting all the plant, animal life, including human. Geosphere includes all the rocks and landforms on the earth. And what we know is that there is exchange of mass and energy within the system, across the system. So there are a few terminologies like reservoir, flux, storage, and cycle. So reservoir is basically the storage unit. Flux is the rate at which mass and energy transfer from one system to another or part of within the system. Storage is the measurement of amount stored in a reservoir. And then cycle is the process in which you from all across the system, any some material or substance moves. For example, water cycle, carbon cycle, nitrogen cycle, and many others are there. Now, talking particularly about hydrological cycle or hydrosphere, because river is part of hydrosphere. So on the figure on the left, is there a way to use mark this in highlighter or indicator?
Yes.
Okay, I hope cursor is visible.
Point out over there and just a second.
Okay, let's continue.
Yeah, you can point out through the cursor.
Okay, so the figure on the left of screen, it shows, let's begin with the ocean. So ocean water evaporates and from hydrosphere, it goes into atmosphere. Here, what happens, one is the rainfall on the land part. If it moves further in the higher elevation, there is snowfall. Altogether, it is called precipitation, but part of precipitation is rainfall and snowfall. Once it reaches the land, in higher elevation, it forms glacier. In lower elevation, either it is locked in lakes or it will infiltrate to form groundwater, and other part, uh, other parts it flow on the surface in the form of rivers. Groundwater also flows. So this is kind of hydrological cycle in its simplest of the form. And across these reservoirs, if we talk in terms of storages, so how much water is in ocean, how much water fluxes through ocean to atmosphere through evaporation, what is the return of water from atmosphere to ocean in the form of precipitation. Similarly, this is movement of water, a measurement in terms of storages, in terms of fluxes. So let's not worry much about the numbers here, but this is how the system is defined, and we try to understand these movements across the system. Again, this is to give you a wider global picture that these are the number of rivers, major rivers on the globe that we have. So majorly we distinguish Earth is 70% covered with ocean and 30% of the land area. But if we further look closely, how much of the area is covered by river system? So the table here shows it's 2.2 million kilometer cube square area. The same is shown in terms of histogram. So there is a very small area that rivers cover on the land. But rivers are the source of fresh water. So this being very small, but it's very important to humans being and life on this earth. Now coming to the question, what is a river? How do we look at it as a whole? So this is a schematic representation. It looks like a human being here. So top area where the river begins, source area, is called zone 1 or sediment production zone. Sediment means when river water flows, it carries small sand particles, soil particles, or rock particles. Together, those are called sediment. Zone 2 is mainly the zone of transportation of that sediment, and zone 3 is further down near the sea, where a river enters a sea or ocean. And that is the area where river divides into number of distributaries. So this is the overall picture of a river. And I want you to remember this zone 1 is mainly known for sediment production. That doesn't mean it's exclusively production. There is a sediment deposition also, but these are the major processes that happen. Sediment transportation in zone 2 and sediment deposition in zone 3. So this is the ideal state of a river. Later, we will look into the other scenario where how rivers are disturbed and how these production zones, a lot of deposition is happening, which is causing floods. So we will be talking about that. Now, how to look at a river. So whenever we identify an entity, natural or man-made, we try to measure its properties. So river can be measured in terms of its length of the river. Discharge means its water. Whatever water is flowing through the river, it is called river discharge. Another river discharge is this sediment, because river water also carries sediment. So two type of discharge river has. Basin area is the area that contributes rainwater or surface water to a river. Then depth of a channel, width of the channel. So here you can see there are several channels, but they have different widths. Again, so sediment load is another parameter. Ecology. So rivers have fish, in fact, a variety of fishes, other kind of plant life, birds. So that forms the ecology. Even smaller lives river has, and those are important for the hydrological system. So they are very much part of a river system. So we cannot say river is just the flowing water. Then navigability of a river. So we cannot cruise through all the rivers. So whether river is navigable, it also depends, because in past rivers were used to transport goods. So this is also, and then hydrological regime means a river in a humid climate is a different, would be very different from a river in another kind of hydrological regime where the climate is very dry. So these are some of the parameters we use to define river types. Okay, so this figure shows some of the lakes, and a very obvious question here is, what is the difference between river and lake? Anyone would like to attempt this question? One major difference. Both are surface water deposits. So river, as we said, it's a flowing water, but lakes are standing water. So mainly the lakes also have a source, rainwater as a source of water, but lake is a standing water. So very quickly, how do rivers form? How do it initiate when rainwater falls on the surface? These are the small rills or gullies that initiates, and these are very small in length. So due to change in Earth's surface gradient, gradually these small first order streams begin to form. Another example of how the river form, we have different sources of water, meltwater, snow and rain. Even the groundwater enters uh, through the groundwater flow into the stream, infiltration water, and all this water together collectively. So for smaller streams join to form bigger streams, and further they join to the trunk stream. This is how gradually surface water accumulate to form river. And this is another example how groundwater contributes to the river, or river contributes to a groundwater. So if you see the top figure, this is gradient of a river flow along the river, and the area of higher elevation where water table is below the river level, water from river contributes to the water table or groundwater. So this part of river is called influent stream. And in the lower elevation, where riverbed is below the water table, groundwater contributes to river water. And if we look into the cross section below, influent stream and affluent stream. So there is another classification of streams based on groundwater contribution to the river or from the river to the ground. Again, I am showing multiple figures of these source to sink, because it's very important to have a good proper visual of the river on the land. So I'm using different figures to give you different clues how a river is actually on the ground. So in higher elevations, there are very steep slopes. As it moves into the plain, the gradient reduces, and further close to the sea or ocean, and now you can also see the width of river in higher elevations, it's narrow but deep. As the gradient reduces or becomes gentle, rivers become wider. So that means it's erodes its banks. Now, so looking into how river landforms in zone 1 or headwater zone. So what you will find mostly is very narrow channels and very large clasts, and which enters into the trunk stream. So smaller streams are entering into trunk stream. So like a picture on your left, it shows very small creeks. So these are very small stream. Creeks is another name for small order channel. They join together to form bigger tributaries, and then bigger tributaries join to form a main river. Based on this network of tributaries and trunk stream, again, we define drainage system. The most common one is dendritic pattern. Dendritic pattern looks like roots or neuron dendrons, it looks like, where smaller tributaries join to the main trunk river, and the overall network looks like a dendritic network. Where there are hills or ridges, so mainstream is flowing and the tributaries are contributing perpendicular to the main trunk river. So this pattern is particular area found, and it is called trellis pattern. Then radial stream, if there is a dome or very old volcano, dormant volcano, not the active one, then if there is a rainfall, it will create radial pattern of drainage because drainage will be on all the side of this dome. Opposite of this is centripetal, where there is a basin or depression and all the rivers flowing into that depression, it forms centripetal. Particular type of rock where rocks have joints perpendicular to each other. So these joints gradually grow, and as these joints grow, these river system form, and this is called rectangular pattern of drainage. Then deranged pattern is where there are many accumulations of lakes between the rivers. So it's a kind of cascading system. What other features we find in zone 1 are valleys and canyons. Valleys are steep, V-shaped valleys. They are very narrow but very deep. And canyons also have a steep wall and narrow bottoms. So basically, it's a V-shaped. So these are called valleys and canyons that we mostly find in hilly areas. And the other interesting thing is that since there is a lot of gradient, so water is turbulent, and these turbulent water flows are formed due to friction with the river bed. And this is why river rafting is very famous in hilly areas. So these rapids are also found only in the zone 1 of river. Another interesting aspect is waterfalls. Wherever river has sudden drop in gradient, the water falls, and there are multiple reasons for that. One reason could be different kind of rocks. So different kind of rocks have different resistance, and this kind of landform can be formed in the river valleys. Famous one examples are for Dudhsagar Fall in Western Ghat, which is 600-meter tall. Another familiar example is Jog Falls on Sharwati River, which is nearly 500-meter tall. As we move into zone 2, where river enters into the plain, from the hilly area, river enters into the plain. So sudden drop in river gradient, and river deposits a lot of sediment, which forms a fan-like feature. So this is like old-time hand fans. So it's like semicircular, and these figures are called these features are called alluvial fans, and these can be like in terms of scale, these can be few of the hundreds of meters or 200 or 1,000 of kilometers wide. Another feature in the zone 2 is where river has a lot of sediment in a wide channel, then river divides into multiple channels. and these multiple channel system with sediment islands, and these islands are very temporary. These are not permanent. These keeps on constructing, destructing. So this kind of river pattern is called braided river pattern, where the river is very gentle and it doesn't have a lot of sediment. It because most of the sediment is deposited, so river doesn't have a lot of energy. It's very gentle plane. So when river doesn't have a lot of gradient or energy, it will take longer paths, and in doing so it creates loops, which we call as river meanders. So meandering stream is also zone 2 feature of a river. And these keeps on changing. So what is important here to understand is that all these features, none of these are static. They are dynamic. They keep on changing on time, but the rate of change is different. And it's not constant also. And what is important for us to understand is how these changes are happening, at what rate, at what magnitude, in what time frame, and how they are affecting our settlements or urban areas. That is where these understanding of these features and these dynamics comes into the picture, why these are important. So talking further about meandering streams, so you can see in time one, there is a stream, and gradually what happens is if there is low supply of sediment and discharge and gradient is low, gradually stream will take a longer path and it will begin to erode on either side banks, and deposition will happen on the inner bank. And gradually this process goes on and river begins to meander more and more. There comes a point where it almost becomes like a hairpin band. And then after some time, so we are looking into time elapse. So at later time, when due to some more rainfall, there is more energy. So what will happen, river will take a shorter path because it has a lot of energy and it can erode this material between this. And so river will become straight. So as I said, these are dynamic processes. This keeps on changing. So this is one example how river change its path. And what is left behind here is kind of oxbow, and we call it oxbow lake. And this preserves the history of river. Looking at this figure, you can interpret that there was a point of time back in the time in the past when river was actually flowing like this, and in modern time we are seeing this as a oxbow lake. This is another example of meandering streams with respect to floodplains and the whole overall valley. And this is kind of deposition happening here, and then formation of oxbow lake. So again, multiple figures I'm using here to explain the meandering streams. Finally, in zone 3, where river enters the ocean or sea, so river gradient is really reduced to very gentle, and what happens, river deposits a lot of sediment in the form of a triangle feature, which is in Greek called delta. That's why this landform is called delta. And river divides into several distributaries. And maybe not all the distributaries are active at a given time. Maybe some of the distributaries river is flowing and then keep on shifting its path across the delta. So there is a very famous example of Mississippi River. So if you look at different lobes marked in different color and labeled as A, B, C. So at different time, although time is given, but I'm not focusing much on a specific time. It tells you shifting of this delta for last 8,000 years. So this Mississippi Delta has shifted its course across this delta, and this is very interesting and very famous study that highlights how river keeps on changing its path. Then There is another definition, permanent river and ephemeral river. Permanent river are also called perennial river or annual river. And ephemeral rivers are also called seasonal rivers or temporary rivers. So they are not permanent, of course, so they are temporary. What is the difference? Of course, as the name suggests, permanent or perennial river will flow all through the year, while ephemeral rivers flow only during this rainy season and becomes dry during the other part of year. In terms of rainfall, of course, permanent river needs humid or temperate climates where there is sufficient rainfall and less evaporation, while in ephemeral, there is dry kind of climate and so low rainfall and high evaporation. So these are the pictorial representation of uh, perennial river and ephemeral river. Now, in terms of river discharge, how to define discharge? So I've been talking about a river energy, like if there is more water, river has more energy, or river has on high gradient slope, river has more energy. So in order to define a discharge, if we look at the river, so this red arrow showing the cross section, flow direction of a river. So this is river cross section, and there is a flow velocity. So discharge means amount of water. So if we can measure this cross section is area, and the velocity with which water is flowing, which is velocity. So together it becomes discharge. So cross section area into velocity. So this is how it is defined, river discharge. Its units are meter cube per second, which is also called cumac. When it's cubic feet per second, it's called cusec. So in order to compare two rivers in terms of discharge or energy, we can calculate discharge of one river and discharge of another river, and that's how we can compare, okay, which is a bigger river, which has more discharge. So it is a way of quantifying river flow and directly or indirectly river energy. Now, what running water works? What is the work of running water? Erosion, because running water has a lot of energy. Again, how that energy is quantified is through stream power. We may touch upon it later, but we can describe it as energy is related with amount of water in a river and what is the slope of the river bed. These are the two main criteria that defines the energy. And based on that energy, if it is in hilly area, river erodes. Erosion means removal of material and transportation of material, earth material, from one place to another through various agencies. Here we are talking about river, but other agencies means wind, or through glacier, which is again a form of river, glacier water. So in zone 1 or hilly area, most of the erosion material looks like boulders or pebbles. It's a rock or smooth rock material. And what happens that river water can directly pluck it from the bedrock or through the action of these whatever it's already carrying. So when river is carrying one boulder and it strike against bedrock, it will also help abrasion. And sometimes if rock is soluble in water, so there are some of the rocks which are soluble in, like calcium carbonate made rocks are soluble in water. So through dissolution also river can do the erosion work. And how these sediment moves along the river. So here one is dissolved form. Dissolved form is soluble. We cannot see. It will be in dissolved form of water in the water. And then if there are very small particles like clay or sand, then they will flow in the suspended form. They won't settle in the riverbed, but they will always be in suspended form. Now the bigger chunks, which are called pebbles or gravels together, so they move through a process which is called saltation. So they jump on the riverbed and with the moving water, they help each other in the transportation. So this process is called saltation process. Now, another two terminologies is river competence. Competence means what is the biggest size of class a river can carry. The river can carry several class, but what is the biggest of them? That defines the competence of a river. Capacity is the amount of material that a river can carry. So these are another two terminologies to define river energy. And in further downstream in low gradient areas, a river, whatever sediment river is carrying, it begins to deposit. And based on deposition, there are several landforms that it creates. We have already talked about alluvial fans, alluvial plains, then floodplains and delta. So this picture, particularly here, shows that river is depositing these sands, and these are called bar deposits. These are called point bar deposits or lateral bar deposits, based depending on their location. If this is between, like an island between the channel, then it is called point bar. If it is along the banks, these are called lateral bar deposits. So this is so far we have talked about river water features of the river, and then river landform and action of water in terms of erosion, in terms of deposition. Now, if we look at the river from its source to sink and we try to measure its length, so in this figure, river is starting from point 1 and you start measuring its length all across its flow to down to the sink. So it will be measured in a few kilometers, a few hundred of kilometers, depending on which river we are looking at. Then height of the point 1, elevation in terms with respect to mean sea level, and elevation of point 5, point number 5 here. And if we plot distance on x-axis and elevation on y, so what we get, and all elevation of all the points across, if we have elevation information. So what we get is we call it longitudinal profile of a river. And generally it's the longitudinal profile, ideal longitudinal profile has a smooth curve. But in nature, river is only in a process of achieving this ideal longitudinal profile. But one or the other process takes it away from this equilibrium profile. Like for example, if you see at this location, there is a sudden drop of gradient. This area is high elevation, this is low elevation. So suddenly this drop creates a lot of energy in the river water, and river start eroding. So basically, this is a kind of hump or nick point in this long profile. So this is a long profile is very important tool how we measure and compare rivers. So its units are mostly, because elevation differences are in meters only. So meter by kilometers, meter per kilometer or feet per mile. Okay, so again, the character of stream changes along its length. So I've been talking about this, but I keep on coming back to these because for the visualization purpose, to get the image, so I'm kind of reiterating. So gradient is steep in the headwater, discharge is low, competence is high, channel is straight. Okay, so these are the conditions in headwater. Why do we have straight channel? Because of stream gradient. So channel doesn't need to divert on lateral side. It has so much energy, it can create its own path. So shortest path is always the straight path. But near the base level or where sea level, where gradient is gentle, discharge is high. So competence is low, but it cannot carry a lot of sediment. So, and that's why all the sediment is deposited. River doesn't have much energy and it takes a meandering path. Now, overall evolution of a drainage system. So, what is the river doing all through its life? Is basically so our land surface is not flat; it's uneven. And why is it uneven? Because through so if we start through at time one, this there is uplift due to tectonic process. Some part of crust has uplifted, and then compared to the base level, which is mostly sea level, there is a gradient. So if whenever rainfall happens, water flow will be from high elevation to low elevation. And this is where erosion will begin. So this is the point where erosion begins, and gradually through headward erosion, this landform will look like uneven, undulated, and dissected by river system. But gradually river is eroding and taking all the material to the sea. So this landform becomes flat, and much later in the time, all the landform will become flat and there would be meandering river. So this is the overall cycle of a drainage system. But that so telling this cycle means doesn't mean that from stage 2 or stage 3 that it cannot go back to stage 1. That can happen. And why would that happen? Because this uplift can occur at any state, any of the states, sorry. So let's say river is in time stage 2, another uplift process happen. Then again river will, whole of the system will be reset to this time 1. So this process is called river rejuvenation. Okay. But overall, theoretically, we have defined it like there is a evolution cycle of any of the landform or drainage system, and this is the ultimate life of a river. Another interesting example of, as I was saying, that river has its own drainage evolution path, but it keeps on changing also. So in picture on the left shows two different river systems separated by a drainage divide or a highland. Drainage divide means a highland which separate two river systems. So through a headward erosion, later in the time, if this system connects with the another river systems, so instead of this river flowing in this direction, here it shows this river diverted. So this is also called stream piracy. Piracy means this was independent stream, but this another stream through headward erosion has captured its flow. So now this river becomes dry. So another reason for drying up of river is river piracy, so which is explained here. Some more examples of drainage evolution is superimposed. So I think I'm a bit late on time, so I'll try to run through. So on figure on left shows you a drainage system and different kind of rock settings. Over the time, this rocks will be eroded. Now, figure 2 shows the time, much later time when all these surface rocks are eroded. Then subsurface rocks have different kind of lithology or different kind of landform. So the drainage which has evolved on surface 1 has been superimposed on surface 2. So this is called superposed drainage system. So these are very rare examples, but a few examples are available. Similarly, antecedent drainage stream. So to begin with, if there is a drainage system and then uplift begins to happen along this line. In figure 2, it is shown there is uplift and the highland is formed, or hill or ridges, mountain range has formed. But if the erosion process of this river was same as the uplift process, then the river will cut through this hill area. And this is called antecedent. On the other hand, if uplift process rate of uplift was higher than the rate of erosion or incision by this river, then river is unable to cut through this range, and then river will take a new course. So again, this is another example of change in river courses. So antecedent rivers, we have mountain ranges called the Himalaya, and a lot of rivers are running through this Himalayan, and you can see a figure on the left shows mountain ridge. So this Yamuna river system, this Ganga river system, these are cutting through these hill ranges. So that means these are antecedent. So through the process, in the process these mountains were in uplift, these rivers were incising at this same rate or even the more than the uplift rate. That's why they were able to incise through, and they antecedent here means the river did not change its path. It is following its older path, ancestral path. So that is why it is called antecedent drainage system. So now let's talk about the hazard associated with river. Flooding is the most common hazard. How to define flood is that when river has too much water that exceeds its valley and water begins to flow out of the valley on the adjacent floodplains where there is civilization, this situation is called flooding, river flooding. Overbank flow of a river is called flooding. Now, what triggers flooding? So there are several factors. So we have to increase water in a valley to create flood. So how can we increase water is through torrential rainfall. Suddenly there is a lot of rainfall happening in a short period of time. So when precipitation exceeds infiltration of rain, then it creates runoff. And for a longer duration, if that happens, then of course the valleys will overflow. So again, flooding can be seasonal. Like every monsoon, there would be flood in some of the areas. So these are seasonal flood. You are quite expecting these kind of floods. So and it is very common in tropical regions where there are seasonal monsoon rainfalls. One of the example on satellite imagery is shown. This is example from 2005. So picture on the left is before the monsoon season. And you can see the Himalayan ranges and then the floodplain, Indo-Gangetic floodplain. But picture on the right, it is after the monsoon during the month of August 2005. And you can really see a lot of channels. So channels is fine. River has more discharge. But in much downstream, then you begin to see these darker areas. All these dark areas represents overflowing rivers. So these satellite images, water bodies are shown in dark color, almost kind of black. So you can see that in upstream it's channel, but much downstream, river has overflown and has caused flooding. So in 2005, these floods in hundreds of villages affected nearly 800,000 people in Uttar Pradesh state of India. Then other kind of flood is flash floods, where there is sudden cloudburst or sudden torrential rainfall. And you can see this water in this picture. It's not clear water, it's absolutely muddy water. That means a lot of flood rainfall occurred in a short time, and it has created a lot of erosion in the catchment area, and all that sediment produced through erosion is being transported through this flood. So this is double hazard, not just water. This muddy water will occupy all the floodplains, and even if it encroaches agricultural areas, then all these farmlands are also gone. So very recent example, if we look into in Himachal Pradesh during this monsoon season, 51 cloudburst caused flash floods are reported. And you can see all this river water is full muddy water because of these cloudbursts, sudden one. Another example from villages in Wayanad district, there was even a landslide, which is another hazard associated with rivers happened, and flash flood example. So we have recent examples of flash flood. Now, how, I mean, as a human, we try to control these floodings. One of the things that we try to do is, so you start with this river, it has a natural levees, we called it. So it's a natural, along the floodplain, it's a kind of ridge. So this is kind of boundary of the river. But we know that this river during high rainfall, it overflows. So what we do is we create an artificial levee, which is higher than this natural levee, and it can protect us from flooding. But even this is of limited use because sometimes there are slumps or landslides happening on this side, and this can be breached. So this is a solution, but it's not like a secured solution. This is one of the uh, solutions that we try to do to save us from the floods. Now, understanding the flood hazard, what we can do is we can keep record of how often a river floods. And over the time, for many, many years, if we have record, when did the river flood? And if we also measure what was the amount of discharge during the flood, and then we can uh, calculate recurrence intervals based on the measured intervals. So what magnitude of flood is occurring after how many years? So that way we can have some understanding of a river system, how often it floods, what kind of a flood recurrence interval a particular river has. So, for example, if we say some very high magnitude flood will have lesser probability. So, 100 once in 100 year, although it's not correct to say so once in 100 year flood means it has less probability, but it doesn't mean that it will happen only after 100 year. Its risk is less, chances are less, but it can happen any of the years uh, during that 100-year time. Just that its probability is less, but a 2-year flood has a higher probability. Again, this is not about occurrence of, it is only the chances of occurrence. It can happen like if you flip a coin twice. So probability is that 50-50 for head and tail. But if you really, it can also happen that both of the time you can get head or tail. So probability is one thing, it's chance of happening, but actual happening doesn't. So this is the tricky part of this approach, is that we say 100-year flood, but that doesn't mean that it happens only after 100 years. Its chances are once in 100 years. Then creating flood hazard maps. So we can define different zones along. So this is a river from left to right, sorry, right to left. And along this river, you can mark the areas which are prone to flooding. And we can prepare flood hazard map for 100-year floods, for 500-year floods, or 10-year floods. So this is another way to know what is kind of flood hazard we have in this area. And then there is another term called risk. So risk means how much property or life is at risk due to that hazard, how much loss of life and property can happen due to some hazard. So these are few of the approaches why we try to study rivers from the scientific point of view. Now, talking about some of the case studies, one of the example is migration of Kosi River. So Kosi River flows from Nepal, and then it enters into Bihar plains, And so this satellite figure shows us a regular flow of Kosi River. So it enters and then it takes a sharp bend. So, and this whole land area is fan, alluvial fan we have talked about, but since it is very big fan, it is sometimes also called mega fan. And on during the time of 18th August 2008, something happened at this point in the upstream close to the border or in Nepal. And what happened, this river suddenly changed its course nearly 100 kilometer or 60 kilometer. So this new course, so all this is abandoned and it began to flow in this path. And it has flooded all this area. So this area was a urbanized area or through the villages. So this was the major havoc, flood havoc happened in 2008. And this shift, you can see like 60 kilometer of shift that river had taken. And the reason was breaching of a barrage. Barrage is created to hold some water in the upstream in Nepal. So that barrage breached, and it wasn't the case where barrage was full and it breached. Barrage was filled only one third of its capacity, but through the percolation, so slow percolation under the barrage structure. Barrage you can think in terms of similar kind of dam. It's not really dam, but it's on. So dams are for hydroelectric electricity, but barrages are just to hold the water. So again, it's a man-made structure, but that breached and this caused into the flood. So you can, some way you can say that some human component was also involved in this flooding event. But what I wanted to highlight is that shift of the river, it can shift some kilometers of distance. And but later, so you will be wondering where is Kosi River flowing now? But later, again, through restoration process, Kosi has restored its previous path. Another example of migration, river migration, is from Yamuna and Satluj River. So I'm sure you might have heard about some past bigger river in Western India. So this map currently shows you Satluj River flowing west, Yamuna River flowing east. But if we look at earlier civilization map, there are a lot of civilizations here in this area where there are very small streams. So this is Northwest India. And Pakistan also shown here. And all these earlier civilization site or Harappan civilization sites are located here where there is no river. So basically, there is a hypothesis that some big river was flowing through this area. And what were those big rivers were this Satluj River and this Yamuna River. So few thousand years back, this Yamuna River was flowing towards west, but it shifted its course towards Ganga, eastward into the Ganga River system. Similarly, later on, Satluj River system, instead of flowing south, it shifted its course towards the Indus River system, westward towards Indus River system. Okay, so I guess this is last slide, and this is to again show how hydroelectricity dams are contributing to our electricity demands. Although dam-based hydroelectric plants are, we mostly depend on thermal power plants majorly for our electricity needs, but some 10-15% of electricity is also produced through these dams. I also had, I could not include that slide, but rivers are also an important source of minerals and materials. Some of the cases, river even have placer deposits of gold also, because river, while flowing from catchment area, it can carry gold-bearing minerals and it can deposit at some particular location. Those are called placer deposits. And sand and sediment is another important material that is mined for construction. from the river. So river has several importance, and so I have kept it mostly focused on uh, earth sciences, but river has a lot of biodiversity as well. So I think, okay, so with this, I will end this presentation, and I will come back to this figure. So initially I showed you zone of erosion, zone of transportation, but what has happened that due to lot of dam construction, we have changed the role of river or function of river across its length. So with this highlight, I would close this talk. Thank you so much for your patience.
Thank you, sir. Also, we have Vijeta here who have raised his hand. So, Vijeta, is there any question from your end?
Yeah, sir, thanks for your overview. Such a detailed discussion on rivers. My question was regarding the last segment that you are describing about shifts in the rivers. So we were talking about Yamuna changing its course from westward flowing to eastward flowing. Uh, if there is no gradient change, how can I mean you mentioned about barrages, but how can it suddenly shift from one direction to another direction altogether? I understand Kosi was a different phenomenon, but here, how was it accounted for?
Yes. So as this figure shows, so you have to imagine that there was a smaller Yamuna here also. I talked about headward erosion and river piracy. So there was a smaller stream. So it's not like when Yamuna was mainly flowing westward, there were no valleys here. It's all about that valley connected here. Or I also talked about alluvial fans. So what happens when alluvial fans river enters the plain? It creates a fan and it keeps on shifting across. So you have to imagine that there were multiple channels, and one of the channel, most active channel, was flowing westward. And later that channel is abandoned and river chose to flow in another channel across that alluvial fan. So it is not like only one defined channel and whole of that shifted to become Yamuna River. There were multiple channels, and it's all about which channel became active at some point of time. And to be honest, so this research is so far we only know that the shift has happened, but how it happened, what was the reason behind that, that is yet to be explored. But there are speculations. One of the famous is river piracy by late Professor K.S. Waldia. So he thinks that the Yamuna, a small tributary of Yamuna, through headward erosion, has captured this sort of past bigger river.
Thank you, sir, for the response and the explanation as well. So our first question goes with, can rivers actually change their flow and direction due to urbanization? Have a few more as well. So basically the question is that can rivers actually change the flow and the direction due to urbanization?
Okay. Yes. So we have seen that rivers do change their flow through natural process. But here the interest is through urbanization. So urbanization, I can think in two terms. One is like when we construct dam on river, it is also part of urbanization. So of course we are diverting river waters through construction of dam using the canals. We supply river water through canals, like for example, Narmada River supplies water all the way to Ahmedabad city. Here also in Bangalore also we get water from Kaveri River. So that is one part of urbanization where through dam construction we are doing. But through urban expansion, so I guess the person wants to know where, as we expand our cities, how we are changing river courses, or so indirectly we are changing the infiltration, because as we become urban, there is less of infiltration of rainwater into the groundwater, and what happens, that water becomes surface runoff. And once that surface runoff reaches the stream, so in a way we are increasing the stream energy. So ultimately, this can lead to a change in river energy and shifting of river courses. So answer is yes, indirectly through changes in infiltration, rainfall infiltration, this can happen.
Okay, sir, we have another question. This is our second question, which comes from Sanvi. And Sanvi asked, what were the early humans' first reaction when they saw the rivers?
Okay, this one is very interesting.
You can
Uh,
please.
so reaction. So as a scientist, I would wonder, how can I find a reaction that happened in the past? So, I mean, just imagine a situation where an early man went to a river, he had some expression.
Right.
Now, today, how can I find a trace of that expression? So, it's really difficult to find the evidence for this. But when we don't have that kind of evidence, so we can try to find an analogy. Like if today we go to a river, what kind of feeling do we have? Uh, I mean, it's different feeling for different people. But of course, I mean, even if early man went to a river is very essential for life. So he must be, I assume he must be very excited to see a river.
Right, right. And we have another question. This is our third question, which is from Shrikant. And Shrikant asked, how do rivers bond?
Okay. So I guess we have really talked about it during this presentation. So of course, through rainwater, when rainwater falls on land surface, and if there is a gradual gradient, so small streams will form. Those will join to form bigger network, bigger tributaries, ultimately the main trunk river. So this is the part of hydrological cycle which creates a river system.
Okay. Sir, we have a fourth question, which is from Leander. And he asked, I want to know how many rivers were there back in 1924, and in the past 100 years, what has been the reason for so many rivers to dry up?
Okay, so in past 100 years, so many rivers have dried up. I mean, well, I'm not very sure which specific rivers the person is referring those dried up.
I think
But
he's referring to a general, the rivers
Mhm.
drying up or
So, okay,
have almost
so the
dried up.
person has taken 100 years of time frame, but
Yes.
rivers flow for, I mean, many thousands and thousands of years. So if you ask what is the age of river Ganga or river Yamuna, they have been there for many thousand years. So 100-year time frame and drying of river, I mean, time frame wise, uh, I don't really understand. But of course, the question is how a river dries up. So for drying of a river, we see an example of river piracy, where in some upstream, another river has captured the catchment area, and downstream part of river becomes dry. So you have to cut water supply in some way. So either the climate has changed so much that rainfall has reduced, so there is no water, river will dry. Or you have created, for smaller rivers, if you have created dams or small check dams in the upstream part, so that also another man-made reason for drying of a river. But as such, I'm not aware of any record like that has where we have studied like how much rivers have dried in past 100 years. That takes a little longer time for drying of a river through natural process.
Right. So we have one more question with it's from Chandrasekhar. And Chandrasekhar asks, how important is it to judicial usage of such resources from where we can inculcate the value-based education through children or adults or houses or schools or communities? So this is what his question is. So basically, his question is that how important is it to judicial usage for such resources?
Okay, yeah, it's very interesting question. How much water we should use from a river or a river using river resources, not just water, or how much sediment we should take out from a river. It's very important. So one of the criteria is environmental flow of a river or ecological flow. So it's again same like sustainable use, so that we don't really destroy the natural system. So the answer would be, we have to understand what is the ecological flow of a river, and we don't disturb that ecological flow, which means its plant life, its animal life. If we cannot, without disturbing those, we can take its reuse its resources so that resources are available for future generations. That would be the best solution for this.
Okay. So we have two more questions left. This is our second last question, which is from Parikshit. And he asks that is it really important to make a dam and interrupt the natural flow of river?
Okay. Yes. Thankfully, I have this slide here, which shows. So, okay, disturbing. I mean, ideally, we should not disturb any of the natural system, but of course, we have to use the resources. So, as I said, a sustainable way. If we can know what kind of discharge we are disturbing. So if we are not disturbing reverse e-flow, then we can do that activity, because electricity is also a demand we have to fulfill, and kind of 10-15% of electricity in India depends on hydroelectric powers. So justification is difficult to answer, but as long as it's sustainable, then we can say it's justified.
And we have our last question, which is asked by Jesse. And Jesse asks that which is the smallest and the widest river in the world?
Smallest and widest
Yes, at the same time.
river in the world. Smallest and widest. I mean, widest rivers are few of the dry rivers in Western India. So a lot of, like one example is Luni River, although it's not very small, but back in the time, Aravali hills were as high as Himalayan mountains. And Luni River system, which is now dry because Aravali range has reduced a lot. So that river system is dry, but it's very wide. But small and wide, okay, that's, I'm not sure exact answer, but I will take Luni as answer for that.
Okay. So we are done with our question segment, and thank you so much, Dr. Ajit sir, for making this session so interesting and engaging. I am sure the students had a wonderful time. Also, a big thank you to everyone for joining us today, and we look forward seeing you again on 27th of December for our next exciting session. The registration links and the further details will be shared with you shortly. Thanks again and have a great evening. Thank you so much, sir.
Okay, thank you so much for the opportunity.
Thank you, sir.
Bye.
Bye, sir.